Okay, now for question number 2 from February-March 2019, paper 4 variant 2. Question number 2 here is about transformations, and part A asks us to describe fully the single transformation that maps triangle A onto triangle B. Triangle A onto triangle B. Now, triangle A onto B, okay, if I just do this, if I take a triangle and I see if it's a translation, you can see it can't be a translation because a translation would look exactly the same orientation as the original. Okay, so it's not a translation. Some people say, it's a rotation of 180 degrees. That's how some people think of it. Okay, now, if it was a rotation, one second, I'll just move that over there. Let me take the one from up here. If it was a rotation, okay, then it would look like this somehow. It would have this type of shape if it was a 180 degrees, so it would be something like that. It wouldn't look the same way as it does here, okay? So it's not a translation, it's not a rotation, so it must be a reflection. Okay, and you see if I do this, if I reflect it, you see it's got that shape, so it's definitely a reflection. Okay, let me put it back as it was. I'm going to need it again. All right, so we know for sure that this is a reflection. Okay, now I can get rid of that stuff. Okay, so we got to find the mirror line. For a reflection, you always have a mirror line. Okay, now a mirror line is a line that joins together a point on the object and a point on the image. Okay, so it's a line that cuts that line exactly halfway. So the line between this point and that point, exactly halfway between them. Okay, the perpendicular bisector of a line joining a point and its corresponding point is going to be the line that we want. So we don't need to draw perpendicular bisectors here because we've got a grid and it's just pretty simple to do without that. Okay, so what I'm going to do is I'm going to show you how to just calculate where it is. So we know that the distance between the point and its image is cut in half by the mirror line, okay, and it's cut 90 degrees. So you see between -3 and 6 there's 9 spaces, okay, 9 spaces between -3 and 6. Okay, if we divide that by 2 we get 4.5. So we know the halfway point must be 4.5 squares along. So 1, 2, 3, 4.5. So it's going to be going through here. Okay, and over here you see you got 1, 2, 3, 4, 5. So 2.5 from here, 1, 2.5. So it's going to be definitely going directly vertically down between those 2 points I've made, and that will be your mirror line. Okay, the mirror line looks something like that. Okay, and the mirror line has an equation, and the equation is, as it's vertical going through a point on the x-axis, is x equals whatever number it passes from the x-axis, which is 1.5. So the transformation that fully describes triangle A onto triangle B is going to be a reflection in the line x equals 1.5. So you say reflection in x equals 1.5. Okay, that's the line x equals 1.5. Okay, so that's how you deal with reflections. It's 2 marks. One to say it's a reflection, one to say or to give the equation of the mirror line. Now it says triangle A onto C. Now A onto C, okay, some people say, that's a reflection, okay, and they think it's reflected, but as you can see here, it's definitely a rotation. If you rotate this A, you're going to get a shape that looks exactly like C. Okay, looks exactly like C. All right, so it's definitely a rotation. Okay, it's definitely a rotation. It's been rotated. Okay, and we got to find the center of rotation. Now this is where it gets a bit tricky. Okay, so let's try and figure this out. There's different ways of doing it. I personally prefer tracing paper. Okay, so first of all, I kind of take a guess of where I think the center of rotation will be. Now tracing paper is very useful in doing these type of questions, and I advise you to make sure that your school provides tracing paper in your exam. Okay, if the examining body that comes doesn't have tracing paper, ask one of your teachers to give then tracing paper on the morning of your maths exams in case you might need it. If you're a private candidate, speak to the examining body before the exam. Take some tracing paper with you, give it to them and say, we would like you to hand out some tracing paper for us in the exam in case we need it. And you can see that's actually something which is provided or can be provided, because it mentions in the beginning of the paper, okay, additional materials, electronic calculator, geometrical instruments, meaning like protractors and compasses, and then it says tracing paper. Okay, so tracing paper is allowed for you to be taken into the exam. And for this topic, sometimes it makes life a lot easier. So I'd advise you to try and make sure that it's available for you. Don't just take it into the exam by yourself without speaking to the examiners. You'll get in trouble taking pieces of paper in. Okay, now, I want to find the center of rotation for this shape. Okay, so what I'm going to do is I'm going to first guess a point. Okay, I'm going to first guess a point that's wrong, just to illustrate what you do. So I know, for example, that the center of rotation is somewhere in this region here. So I'm going to choose, for example, this point. Okay, I know now, right now, that this is wrong, but I'm just doing this to show you how to deal with this type of question. So I'm going to now put the tracing paper. Okay, I'm going to do a little trick with it that you might not realize, but okay, that will make it rotate right in the center, what I've called the center. Okay, so now I'm going to trace on top of my on top of the triangle. I'm going to trace a triangle on the tracing paper. Okay, I'm going to make sure it's on the tracing paper. Whoops, what happened there? I'm going to make sure that it's on the tracing paper. Okay, so I will now group it together with this, so they move together. So group. Okay, and see, this is the center that I've chosen. Now, if I rotate it about the center, you see no way does it fall exactly where it needs to. Okay, it's further to the left and too high up. So that means I've got to go down and further to the right. Okay, so let me choose a point like, I have to ungroup it again. This is going to take a bit of time, but it's worth it. Okay, so I want to ungroup it again. Okay, I'm going to choose a point now which is further to the left. Okay, or sorry, further to the right. So let me ungroup this. Why does it not ungroup? Okay, let me just. Okay. Now, yeah, that's fine. So I'm going to choose another point for my center of rotation. So I'll move my center to say over here. Let me see if that works. Okay, that means I've got to go 6 here and 7 there. Okay. Okay, so now I'm going to trace the object again. Okay, on the tracing paper, straighten it up. I'll trace it on the tracing paper again, make sure it's exactly over my original object. Okay, and then try to be accurate, and then I'm going to group it together with this so that it's like sticks to it. So I'll group it together. Okay, now I'm going to rotate this about the center that we've chosen here, and you see this time it fits exactly, or it should fit exactly. I haven't quite centered it right, but it would fit exactly if you did it properly. Okay, that would fit exactly over there. Okay, so you have, I've gone slightly to the left a bit, that's all. Okay, so therefore we know that this is definitely the center of rotation, 0, -1. Okay, so you can just use, you know for sure that the center is somewhere in this region here. It can't be out in the middle of the sticks over here somewhere. It has to be somewhere between these 2 points over here, somewhere in this region. So what you do is you choose a point. We chose one point and we found that it didn't take us to the right place. It was too much to the left and too high, so we went lower and right, and you could have tried a couple of different places. Eventually you'll get there. Okay, with a bit of practice you'll probably get there a lot quicker. Okay, so we can see that this is a rotation and it's a rotation of 90 degrees, and it's anti-clockwise, and it's about the point 0 minus 1. So you have to write all those things down. You have to mention that it's a rotation. Okay, and you have to write down it's of 90 degrees. So you say rotation. So you first state what type of transformation it is, rotation. And then you state, okay, it's 90 degrees. Okay, that's the second thing they need. Then you state it's anti-clockwise, the direction it's in. Anti-clockwise or clockwise, this is anti-clockwise because it's going in this direction, anti-clockwise. Okay, and you also state the center of rotation, so you can say about, and the point was 0 minus 1. 0 on the x-axis, minus 1 on the y-axis. So that's fully describing the rotation that's taken place. Okay, and now, okay, so for part B, on the grid, draw the image of triangle A after enlargement, after an enlargement, scale factor -0.5, center 3, 0. Okay, so let's get rid of some of these things here. Okay, let's move this out of the way. Okay, and okay, we got that. Just clear up, tidy up some of these things. Okay, now we want to find the enlargement, scale factor -0.5, center 3, 0. So enlargement, scale factor is -0.5, and the center 3, 0. Is that what you said? 3, 0? Yeah, okay. So 3, 0 is over here. This is 3, 0. So that's the center of enlargement. And when I'm dealing with enlargements, I like to use vectors when I have a grid. Okay, it makes life a lot easier. So we've got to find the enlargement of triangle A. Okay, of triangle A. So what I do is I take my center of enlargement, okay, and I find the vector that takes me from the center of enlargement to a point on A. So for example, this point here. What's the vector that takes me from this point to that point? Well, I've got to go to the left 1, 2, 3, 4 spaces. So it's -4, okay, 1, 2, 3, 4, and then it's 2 up. So -4, 2. All right, so that's how I get from the center of enlargement to this point on A. Now, if I then take this and I multiply it by -0.5, okay, that will give me how to get to its image from the center of enlargement. You always start from the center of enlargement and you go towards the shape, always from the center. So -0.5 times -4 is +2, and -0.5 times +2 is -1. So you have 2 and -1 as a vector that will take you, okay, from our point to the image. So you're going to go 2 spaces to the right and 1 space down. So that is a point on the image. Okay, so I'm going to just show this in a different way. This is our center. I'll just put a blob here for now. But that's one of the points that we need, okay, to draw. That's the image of this point basically. Okay, and we can do the same thing for this point. We can say, okay, from the center of enlargement, okay, let me call that C. From the center, I shouldn't call it C because we already got C, it doesn't matter. Let's call it P, the point of the center of enlargement. Okay, you're going to have 1, 2, 3, 4, 5, 6. You have -6 and you have again 2. Okay, so if you multiply that by -0.5, you're going to get 3 and you're going to get -1 again. Okay, so you're going to get 3. So from here you got to go from the center. You always start. You got 1, 2, 3, and down by 1. So you end up at that point. That's the other, and you can see that it's half the size. Okay, it's half the size. And we should realize that this is 1, 2, 3, 4 spaces. So this is going to be 2 spaces. So I can imagine that the last point is going to be there. But because it's a negative scale factor, some people might be confused. Is it this side or that side? So again, just if you're not sure, you can just use minus a half times a vector that takes you from the center to the object. So you're going to go for this time minus 6 and plus 6. So you multiply that by half, you're going to get 3 and negative 3. So from the center to get to the image, you've got to go 3 to the right. Okay, so it's 1, 2, 3, and 3 down, 1, 2, 3. So you can see it's that point over there, and we can now draw the image, which is going to connect these points together. Okay, and does it tell us to label it? No, we can just say that that's the answer to part 1. That's the answer to B part 1. B part 1. Okay, you can just make a label there so you can see that that's the answer to B part 1. Okay, so that's how you deal with, that's how I like to deal with enlargements. When I have a grid, instead of using a ruler and measuring lengths, I like to use vectors. Okay, and normally you can choose, you can locate one point, just one point with the vector, and then you can work out how the other is going to be, because, for example, we know the length of this is going to be the half the length of that, because the scale factor is a half, but it's also going to be inverted. So because sometimes that causes confusion for some people, using vectors for all of them is absolutely fine. All right, to save that confusion. So that's part B, part 1 done. Then it says draw the image of triangle A after a translation by vector minus 3, 1. Okay, so now let's get our triangle back here. So we're going to translate it by vector minus 3, 1. You could even use a tracing paper for this if you want, but it's not really necessary. Okay, so you know that the whole thing has to move 3 spaces to the left and 1 up. Okay, because it says translation of negative 3 and 1. So you've got translation of negative 3 and 1. Okay, so you can say, all right, this point goes to the left 3 spaces, 1, 2, 3, and up 1. So you know that this point's going to be over there, and this point's 2 spaces to the right of it, and this point is 4 spaces above it, 1, 2, 3, 4, and we can see that that's what's going to happen if I take this shape. Oh, it wants to be cut apart now. Take this shape and move it. Oh well, that's torn it, hasn't it? Okay, so you got every point has moved 1, 2, 3 to the left and 1 up. Okay, so that's now the answer to B part 2. This is B part 2. Okay, 3. This everything's 3 to the left, 1 up. That's translation minus 3, 1. Okay, that's that part of the question done. And then it says triangle A after the transformation that is represented by the matrix 0, 1, 1, 0. Now there's a number of ways you can do this. One of the ways you can do this is you can actually multiply the vertices of your object by this matrix. So you can say, okay, let's take the object, which is A. Let's take the coordinates of these points. So you have minus 1, 2. So you write the y coordinate on top. So minus 1, 2, that's that corner. So you've represented that coordinate as a matrix. And the other point is minus 3, 2. The other one is minus 3, 6. So you have minus 3, 2. So the x value is on top, minus 3, 2. And minus 3 and 6. And when you multiply these two vectors together, you should get the 3 points of the image. Okay? So if you do that, you have 0 times minus 1 plus 1 times 2. That's 2. And 0 times minus 3 plus 1 times 2, again, that's 2. 0 times minus 3 plus 1 times 6, that's 6. And for the bottom row, 1 times minus 1 plus 0 times 2, that's minus 1. 1 times minus 3, which is minus 3 plus 0, is minus 3. And 1 times minus 3 plus 0, which is, again, minus 3. Okay, so that's one way of doing it. And you plot those points and you get your image. The other way of doing it is to work out what this actual matrix does. Now, we always start off with I and J in these positions. And you see this is the image of I and this is the image of J after the transformation has taken place. Okay, so I is always on the x-axis, J is always on the y-axis. Now, the new position of I is 0, 1, which is up here. Okay, that's the new position of I dash. And the new position of J is 1, 0, which is over here, where J was, where I was, sorry, okay? So we can see I and J have swapped places in this transformation, okay? What makes them swap places? A reflection in the line y equals x. This one requires a bit more thought, but once you get used to it, it's quite easy. This one's more calculating, but let's just show you what we get. 2 minus 1, 2 minus 3, 6 minus 3. 2 minus 1, and it was 2 minus 3, 2 minus 3, and it was 6 minus 3 over here. Okay, so if I join them together, I have this triangle. Okay, that's the answer. It says, say draw it. Yes, that is the answer for B part 3. That's B part 3. B part 3. 1, 2, 3. Okay, so there we have, and we can see what we mentioned here, that this is the reflection in the x-axis. It's a reflection, reflection in the line y equals x. Reflection in y equals x. We can see that's exactly what that image is. It's reflection in the line y equals x. If I was to draw the line y equals x, it would cut through minus 4, minus 4, minus 5, minus 5, 0, 0, and so on, 1, 1, 2, 2, 7, 7, all the numbers are the same both in x and y, and you can see it's a reflection in that line. Okay, so you could reflect in that line if you wanted to, or you can use the matrices to multiply to find the image. But if you were to reflect in this line, you would say, okay, this point is 1.5 spaces away from the mirror line. If I continue the mirror line perpendicular, if I continue this line perpendicular to the mirror line, you're going to have 1.5 spaces on the other side. You have a half and then 1 more. Here, the perpendicular distance between this point and the mirror line is 1, 2.5 diagonal squares. So 1, 2, sorry, a half, 1, 2. That's where that image is. That point is going to be, and so on. This point is 1, 2, 3, 4.5 diagonal squares away, and this is 1, 2, 3, 4.5. 1, 2, 3, 4.5. So yeah, it takes us to the points that we need. Okay, so we know 2 different ways of dealing with these type of transformations when we're given a matrix. Okay, so that's question number 2, part A and B.